All right, may I have your attention, please? We're going to start the second session of the Tech Talk session, and I'm glad to present to you John Damalas. He's the IT leader from GE Transportation, IT leader in analytics and BI, GE Transportation. His topic today is harnessing big data for industrial internet. John leads the strategy and capability development for big data, analytics, and BI for Transportation Global Services at GE. Prior to his current role, John has held various positions throughout GE, including being the BI leader at their nuclear business and also serving in the corporate audit functions. John has experience in multiple industries, ranging from finance, manufacturing, engineering, to treasury. Please join me in welcoming John, and I'm glad to present John Damalas. Thank you.
Thank you very much. I'm going to talk a little bit today about the industrial internet, GE's strategy around how we harness tools and technologies around big data and analytics, and eventually connect them to customer outcomes. So, give you some context. We think about the industrial internet, where we're in the evolution of human history. Talk about a little industrial internet, how we down into some different pillars we focus on, enablers, catalysts, and conditions, and then get to the fun stuff and talk about how specifically that relates to what we're trying to accomplish in GE Transportation, and then subsequently where big data plays a big foundation. Now, I thought I would start with a very simple, very important question, and that's why. Why should we care? Why are we doing all of this stuff? Through several of the sessions today, if you just talk about big data, analytics, sensors, if you don't have the why in mind, it's all. Analytic doesn't do anything by itself. A neural net doesn't do anything. Having exabytes and whatever's bigger than an exabyte of data doesn't do anything unless you can direct it to an outcome. So, especially at a company as large as GE, we need cohesive charters to really rally a beast like that to a single vision. And the way we think about the why is the power of one. So, as you can see, we took a look across several of the industries that we play a primary role in, and we saw some astounding numbers when you just look at the raw power of 1%. You take the aviation industry, for example. The net effect of a 1% increase in fuel efficiency for commercial aviation over 15 years equates to about $30 billion. And you see similar effects in a number of other industries where we play. So these aren't small numbers, and when you add them together, being able to direct the capability of big data and analytics at these industries at scale are producing a step change increase in industry as a whole. So now that we have a little bit of the context of the why, I'll just take a few moments and talk about the industrial internet. And we really look at this as the third wave of innovation that we've seen in semi-recent history. The first being the Industrial Revolution. And really that was machines in factories powering economies of scale. So being able to automate tasks, redirect labor and workforce from manual creation, manual manufacturing, and really achieve economies of scale. The second one being the internet revolution. Now this achieved two primary goals. The first being spurring a dramatic rise in the power of computing power, and a dramatic decrease in the cost of that technology, as well as giving rise to more information and service-oriented industries. Really, the industrial internet is a culmination and combination of those two phenomena. So taking the economies of scale that we can achieve through the output of the Industrial Revolution and the culture of collaboration and the technical innovations that have given rise from the internet revolution, and being able to combine those two and again achieve another step function increase in economic scale particularly in the industrial segments. So really we think about the industrial internet in three key pillars. One, intelligent machines. Two, advanced analytics. And three, people at work. And I'll go into a little bit more detail on what I mean by that. So first, intelligent machines. So this is really about connecting the world's machines, facilities, fleets, and networks, not only with themselves, but with the world around them through advanced sensing technology, controls, and software applications. So really this is about making devices smarter and, at the risk of being provocative around Skynet, more aware, more self-aware. And really being able to leverage intelligence not just at a machine level, but also when you look at a fleet level and ultimately a network level, gaining increasing levels of intelligence from those machines. Now, advanced analytics, and we've heard in several of the previous presentations that the most effective analytic models and algorithms don't just rely on a single methodology. So looking at the power of physics-based models, particularly at a company with GE where we manufacture, we're the OEMs of most of the industrial equipment in the industries that we serve. We can leverage that knowledge of how these assets are designed to perform. Predictive algorithms, so you talk about the things like the neural nets, regression analysis, clustering algorithms, and other statistical tools of that nature. Automation and deep domain expertise. So being able to leverage the knowledge of how these assets were built, how they're normally operated, in what environments they're normally operated, combining all of those to, again, increase the effectiveness of those analytic algorithms. And then the third one is people at work, because unless you can take the data that you can glean from intelligent machines, the output of those advanced analytics, however sophisticated that they end up being, if you don't connect them to people that can either make decisions or can act on that information, you have a really expensive server sitting in a closet somewhere. So this is really connecting people either at work or on the move, anytime to support intelligent design, operations, and maintenance, obviously to achieve higher levels of service and quality. So, that's really how we bring these things together in this concept of this notion of industrial internet, is again, leveraging the recent advances in technology to be able to store and process the vast amounts of information generated from these intelligent machines. Being able to gain new insights from new analytic modeling techniques acting upon these new rich sources of information, and ultimately connecting those to people that can make decisions geared towards specific customer outcomes. Now, we really think about four major enablers, conditions, catalysts within the context of the industrial internet: innovation, infrastructure, cybersecurity, and talent development. So first, innovation, not just innovation, technical innovation with regards to equipment, mostly now around sensing technology and also the ability to transmit data from assets wherever they're at to the places that you can act upon this data. So, we alluded to it before. Personally, I'm in the transportation business, so we manufacture and we service primarily freight locomotives. Those locomotives could be in the mountains of Kazakhstan. They could be going between Chicago and New York City, all with varying degrees of connectivity, varying degrees of climates, operating conditions, track grades. So being able to understand what data we want to generate from those assets and then be able to transmit it in an appropriate way. Being able to innovate around analytics, so either taking modeling methodologies that potentially were limited in the past due to compute and storage roadblocks, and being able to apply them to these new rich sources of data. Innovating around system platforms, so designing new architectures and platforms that can support this end-to-end industrial internet process. And then finally, innovation around business process. So things around how do we monitor data quality? When, why, what's important, as well as things like legal implications of being able to have more flexible and faster arrangements between firms for the purposes of things like collaboration, co-development between firms and customers, sharing agreements between vendors and suppliers, so that the technical innovations can be protected through appropriate policy and contractual language. Infrastructure, this one's sort of straightforward. Obviously, more data needs more data centers, faster network, robust network. Any advances in hardline networking, broadband spectrum, wireless connectivity can benefit particularly these assets that are constantly in motion. And then specifically power. A lot of data centers, a lot of assets, innovations around power efficient equipment to be able to realize this growth in a sustainable manner. And then I couldn't forget cybersecurity, especially since my CIO for cybersecurity is sitting in the audience. But this is really around a number of different areas. The first being technology vendors. So making embedded security as high a priority as design and functionality. Asset owners, being able to manage physical security to those, whether they be at rest in a facility or in motion. Regulators and policymakers. So promoting a culture of innovation through consistent standards and processes. And then the last one, particularly for a multinational corporation like GE is important to us, is international institutions. So it's great to have robust policies in your home state, but when you conduct business in such a globally collaborative culture, being able to have things like consistent intellectual property protection and consistent policies around things like server localization requirements to not present an additional barrier to entry or to innovation internationally. And then the last one is really talent development. I think this has been touched on a few times, but there's really three main areas where we're focusing on talent development. The first one is next generation engineers. So, the day of just being an electrical engineer or just being a mechanical engineer or a computer scientist, is going away. Really, the new breed of engineers to work on these types of problems have, both the mechanical know-how of how an asset is or should perform, and be able to marry that with, the computer science, the software development domain expertise to be able to, sense, understand, and process how that asset is performing. Data scientists. This is around algorithm development, not just statistical know-how, being able to understand things like the physics-based models. So again, you can achieve higher levels of efficiency in your analytic model development. And then UI design. And this is not just your typical, UI, UX designer that you think of that, develops mobile applications or websites, but really from human to software interaction all the way to human-machine interaction. So it's going to be a combination of, the software UI that's particularly on an asset, married with the physical UI of how that machine performs. So now this is sort of the fun stuff. So how are we looking at taking advantage of this as GE Transportation? So really, we're focused in three main areas. One is building a smarter locomotive. So making sensing technology as high of a priority in our NPI lifecycle as increases in efficiency and additional functionality. Being able to leverage a lot of the big data storage and processing technologies. We are currently co-developing what we're calling the industrial data lake. Nate mentioned this morning we've created a GE software center in San Ramon, a large investment there, and we're seeing benefits of that data lake, particularly in the aviation industry as a starting point, and then eventually expanding and building upon that benefit and that compute infrastructure across the rest of our industrial segments. And then connecting that to people at work through applications built on a platform called Predix, which is it's a platform for application development and runtime being developed by our Software Center of Excellence that we can use as a baseline and build these predictivity solutions to present data gained from assets, processed through analytical models to a forum where they can take decisions. And really how we think about the benefits of the industrial internet, it's all about optimization. And this gets back to the why. So being able to identify what's important to our customers and specifically map our solutions and articulate how the benefits of those solutions impact their metrics is incredibly important. So in the transportation industry specifically, there's three main areas we're focused on. Asset optimization, network optimization, and operations optimization. So when you think of asset optimization, it's both the efficiency of the asset. Just like any other sort of transportation, aviation, motion-related type industrial segment, fuel is one of the highest operating costs for our customer. So that's something specifically we're focused on. We have a product called Trip Optimizer, which is a combination of hardware elements and intelligent software that can take things like operating parameters, how the asset is being operated and where it's being operated, and help influence and advise the operator or the engineer that sits in the cab on how to operate, either speed up, slow down, given the track grade, and the time to destination to maximize the efficiency of that asset. Reliability, is always, always a prevalent concern. Being able to maximize the time that an asset is on the track, is hauling freight, is, again, when you talk about asset optimization, the other big focus for our customers. On the network velocity, so this is different than velocity of, when we talk about data velocity, one of the V's. Network velocity is the average measurement of miles per hour of all assets on a network segment. So when you can increase that by a single mile per hour, that just presents an incredible value to our customers because they can increase their ability to haul freight without any additional capital outlays for additional assets. And then more traditional operations optimization. So looking at how we execute repair operations to optimize for cycle time, labor costs, material costs, and other factors. So really, I think I'm contractually obligated at a big data presentation to have some slide with some V words on it. So, this is my obligatory volume, velocity, variety. Particularly in transportation, our big data problem doesn't relate to volume. It really is more velocity and variety. So marrying machine data with weather data, with topographical data in a manner fast enough to be able to give those insights to an operator in enough time for him to actually act appropriately. And really, one of the last things I'll leave you with is, technology is only a piece. It's really about the people in the process. So, with senior leadership being able to articulate how big data isn't just an IT problem and benefits extend beyond just cost reduction. Getting our line of business partners to think again about beyond current capability, and then technical execution to grow talent and to take into account those considerations and constraints that we previously talked about. So with that, big data is an important piece and a core capability of the industrial internet, and is poised to just deliver incredible value. So I'd like to thank you all for attending, and I'll be around for the rest of the day if you'd like to connect more.